Web3 is the future of the internet where you are in charge. Imagine a digital world powered by blockchain, making everything secure and transparent. It's a place where websites and apps operate without any central control, and you own your data, not some big company. With Web3, the internet isn't just smart, it's fair. You can trade, interact, and create in a fully decentralized digital universe. In this video, we will get ready for entering the crypto universe. You will finally understand what is blockchain, what is crypto, how does all of that work, and learn the lingo. After this lecture, you will be comfortable with talking about all things Web3 and will think about crypto projects with solid background. So, let's build up your Web3 knowledge together. We will start with what is blockchain and how does it work? Then we will continue with the approval mechanisms and take a closer look. We will continue with top 20 crypto coins by market capitalization, top 5 blockchains by utilization, Web3 dictionary with explanations and examples of all the most important topics, and the bonus, top 5 media newsletters if you want to stay on top of all news crypto. At its core, a blockchain is a decentralized ledger or a database that records transactions across numerous computers in such a way that the registered transactions cannot be changed afterwards. Each block in a blockchain contains a set of transactions that are considered to have occurred around the same time. A block has a limited capacity, so once it's filled with transactions, a new block is created and linked to the previous one. Blocks are linked together in a sequential chain using what is called hashes. Hashes are unique digital fingerprints created by a hash function from the block's contents. Each block contains its own hash and the hash of the previous block. This chaining ensures the integrity of the transactional history. If any block's data were modified, its hash would change. Let's have a look at what are the hash functions. So I'm using the online tool to illustrate the hashes and how does it work. I'm taking the example of the SHA-256 because that is the one that is used in Bitcoin. How the hashes work. I write any input right now. For example, I will text A sent to B, 1 Bitcoin. And I will ask the online tool to show me the hash of this. So this big number is the hash. Now, if I change any symbol, the hash is changing as well. Now, the beauty and the magic of it is that I can hash a text or hash any information and receive a string of what looks to be completely unreadable numbers and letters. And I cannot just having this number of letters and numbers modify it into the original text. This is one of the core elements of how blockchain is working. Because to understand what was hashed, we will need a private key. A private key that we are going to talk about a little bit later. No matter how big or small the data, a hash function turns it into a fixed size string of characters that looks random, as you have just seen. Thanks to hashes, it's not possible to cheat or change information in the blocks. Now when you got about the blockchain itself and how it is tamper-proof, meaning that information cannot be changed once it is on chain, let's see how the new blocks are added. The blockchain network consists of nodes, which are individual computers participating in the blockchain. Each node has a copy of the entire blockchain, and they work together to validate new transactions and blocks. How does this node or computer know which transaction to validate? All starts with transaction propagation. When a user initiates a transaction, let's say I send 0.1 Bitcoin to my hairstylist, this transaction is broadcasted to the entire network. The transaction includes information such as sender's address, so my address, recipient's address, address of my hairstylist, the amount to be sent, and a digital signature to prove the ownership, so my digital signature. very similar to a bank transfer. Then comes the mempool inclusion. When my transaction is broadcasted to the network, each node checks its validity by verifying the digital signature to confirm that the sender, me, has the necessary funds, 0.1 Bitcoin, and that the transaction hasn't been tampered with, so was not modified. If the transaction is valid, it is added to the node's memory pool, or mempool for short. The mempool is a collection of unconfirmed transactions waiting to be added to the blockchain. Then, transaction selection for mining. Miners, which are specialized nodes with advanced computational power, select transactions from the mempool to include in the next block that they attempt to mine. Miners typically prioritize transactions based on the following factors, such as the transactions with higher fees would be typically given a priority, because then the miners could get potentially a higher reward, or the size. The larger transactions require more computational effort to process and include in a block. So miners may prefer smaller transactions, actually, and not the larger ones. And then, of course, the age of transaction, the old transactions also get sometimes at some point confirmed, because out of fairness. Then comes the mining process. Miners compete to solve a cryptographic puzzle, proof of work in Bitcoin's case, for the current block. The first miner to solve the puzzle gets to create a new block, which includes the selected transactions from the mempool. Next, validation by the network. The new block created by the winning miner is broadcasted to the network. Other nodes in the network receive and validate the block to ensure that all included transactions are valid and meet the consensus rules. If any node detects an invalid transaction within the block, it rejects the block, and the miner's work goes unrewarded. So, no Bitcoin. Then goes the consensus and confirmation. Once the majority of the nodes in the network validate the new block and agree that it conforms to the consensus rules, the block is added to the blockchain. This process confirms the included transaction. It is important to note that a blockchain can be private or public. A public blockchain is the one where anyone can join and participate in. And the private blockchain means that you need to get a permission from someone to participate in the network. In my course, I do not talk about the projects built on private blockchains because they miss the whole point of decentralization and are not much different than the private database. Decentralization itself means that there is not one central authority that can make decisions for you. Nobody can just shut down blockchain. Nobody can just take away your money. Nobody can just change the rules. Yes, but there is more to it. And it's not that black and white. Decentralization is more like 100 shades of gray, where in theory many things are possible, but not so probable. For example, there is around 18,000 Bitcoin nodes in the world, and the whole database of all the Bitcoin transactions, starting from the first one back in 2009 and up to now, are stored on each of them. It is theoretically possible to destroy all 18,000 computers more or less at once. Yes, theoretically it is, but is it probable? I would not say so, since they are distributed all over the world. More or less as probable as not having electricity any longer in the whole world. Or let's think of what else can happen that will break the blockchain. For example, the 51% attack. That's when a group of nodes controls more than half of the network's mining power and conspires together, allowing them to manipulate the blockchain. That would take many thousands of entities or people to conspire. Is that theoretically possible? Yes, but how probable is that? In case of Bitcoin, maybe not that probable, but what about other blockchains that have much less nodes? Ethereum has only around 8,000. This is how blockchains work in principle, but of course, there are some differences when we get into the details between different blockchains. The main difference is the consensus mechanism. In other words, how do different nodes or computers agree which transactions to include. That's why approval mechanisms is a very important topic. The first consensus mechanism was proof of work, which is used for Bitcoin. It works by requiring network participants, known as miners, to solve mathematical puzzles in order to validate transactions and create new blocks on the blockchain. However, it is also slow, but slow on purpose, making it more secure. So nothing is perfect under the sun, and because of the criticism that it takes too much energy to mine bitcoins, meaning produce the blocks of data, there has been lots of alternative ways to reach consensus. One of the most popular alternatives is proof of stake, as used by Ethereum. Instead of miners, POS, proof of stake, has validators. Validators are chosen to create new blocks based on the amount of cryptocurrency they are willing to stake or lock up as a collateral on the network. The more you stake, the higher your chances of being chosen as a validator. But there is also some element of random selection. Instead of receiving a block rewards like in a proof-of-work systems, validators earn transaction fees as rewards for their efforts in securing the network and validating transactions. Validators who act dishonestly or fail to validate effectively can have some or all of their staked cryptocurrency taken away, a process that is called slashing. All the other consensus mechanisms are way less popular than proof of work or proof of stake, with variations to this mechanism, of course. However, some of them are fair to mention, such as proof of authority, that is a consensus mechanism that relies on the reputation and identity of validators instead of staking tokens or computational power. In POA systems, validators are pre-selected and are known entities within the network who stake their reputation to validate transactions and create new blocks. Another one is delegated proof of stake, DPoS. It is a variation of POS, as you probably noticed, where token holders vote for a small number of delegates or validators to produce blocks and verify transactions. EOS and Tron are examples of cryptocurrencies that use this one. Another one is proof of history. It is used in conjunction with POS and POW to enhance the overall consensus mechanism. It creates a verifiable and immutable timestamp that can be used to order transactions and blocks. One example of such a blockchain is Solana. Another one to mention would be proof of space, and this one relies on allocating and proving storage space on a device rather than computational power or stake. Participants in PO space allocate hard drive space to the network and provide proofs of that allocation. Chia is, for instance, one of those. And now, let's look at the top 20 crypto by market capitalization. For that, you can always safely navigate to CoinMarketCap and look at the latest data. So number one to date is Bitcoin. It was created back in 2009, and its mission is to be the decentralized digital currency. But many people refer it to as digital gold, meaning that users use it to hedge against inflation. Maybe a special fact about it, Bitcoin has a fixed supply cap at 21 million, and that's called scarcity. No entity other than the user can determine how to use funds, and that's called sovereignty or censorship resistance. And anyone can send it anywhere for a flat fee, and that is portability. The second largest crypto is ETH. That is, of course, the native currency of Ethereum blockchain. Its mission is rather to be a smart contract platform and to create a decentralized platform that enables those smart contracts and decentralized applications, or DApps, to be built and run without any downtime, fraud, control, or interference from a third party. The platform aims at global accessibility, censorship resistance, and security. The use cases are numerous, as you will see later from the lectures. It is gaming, identity verification, and so many DApps and DeFi applications. The third largest one is USDT, or Tether. It is a stable coin, and we will actually have a separate lecture about the stable coins. It is issued on multiple blockchains, including Bitcoin, Ethereum, Tron, and others. And its main use is to be minimizing volatility. Number 4. BNB, Binance Coin. The mission of this one is simply supporting Binance exchange operations. It is used on Binance for transaction fees and trading. That's the main goal of it, to provide an alternative way to pay for fees on Binance platform and to power the operations of the whole Binance ecosystem. Of course, it has evolved way beyond the payment for the fees, including payment processing, travel bookings, entertainment, and so much more. Number 5, Solana, with its proof of history mechanism. It is created to be a high-speed blockchain and through its high performance, enable scalable, user-friendly apps for the world. Its use cases include decentralized finance, decentralized apps, NFTs, and gaming, leveraging the fast transaction speed and low costs. Number 6, XRP or Ripple. The main idea behind this one is the real-time gross settlement system. It also wants to be fast and affordable, but also reliable for cross-border payments. With lower cost, it is compared to traditional banking system quite often. What makes Ripple special is its consensus ledger technology, which doesn't require any mining and results in faster transaction confirmation and lower energy consumption. That's why the idea of it is to be used for fast international transactions. Number 7, USDC or USD coin. It is another stable coin, which is hugely popular. We're going to talk about it a bit later. But what is important to know is that it combines the stability of the dollar, or relative stability of the dollar, with the efficiency of the blockchain technology. Next one on the list is Cardano, or ADA. The mission of Cardano is to provide a balanced and sustainable ecosystem that addresses the needs of its users, as well as regulators, combining privacy with regulation, which is a very complicated thing to do. Its use cases include education, retail, agriculture, government, finance, healthcare, and whatnot. Cardano is special in the way it's built because it's built on a scalable and robust platform designed through peer-reviewed research, offering advanced features that are engineered for efficiency and sustainability. And of course, it's also used for smart contracts and dApps. Next one, Avalanche. Its mission is to create a highly scalable blockchain platform for decentralized applications and custom blockchain networks. It's known for the speed, for the low fees, and eco-friendly consensus mechanism. Next one gonna be funny. It's Dogecoin. It was literally created as a joke in the beginning. It's a joke based on a popular meme, but evolved into a digital currency with a strong community. It's used for tipping online creators for small transactions or charitable donations. It's special because it is actually a joke coin, has a very large supply, low transaction costs, and makes it accessible and friendly and inclusive for the online community. Next one, Polkadot. Here the mission is a little bit different. It is the interoperable and scalable multi-chain network. So Polkadot's mission is actually to enable different blockchains to transfer messages and value in a trust-free fashion, sharing their unique features while pooling their security. It's special for its parachain architecture, allowing multiple chains to operate independently within a single network, improving scalability and interoperability in the blockchain ecosystem. Use cases include cross-chain transfers, decentralized finance, and connecting private and consortium, chains with public networks. Next one, Binance USD, another stable coin that we're going to see later, used for a cash, digital cash. It is special and notable for its high liquidity, wide acceptance, and use across various digital platforms. It is used for trading, payments, and as an asset. Next one looks like a joke as well, Shiba Inu, and it's a rather experiment in decentralized, spontaneous community building, because it also started as a meme coin, just like Dogecoin. So aiming to be a bit of fun, but also to be a social community building experiment. I guess you could say it's loved by people who love to joke. Number 14 already, Chainlink. And the mission of it is a decentralized oracle network to enable universally connected smart contracts, allowing blockchains to securely interact with external data feeds, events, and payment methods. It's special for its decentralized oracle network, which provides rather reliable and data for complex smart contracts. It is used in DeFi, insurance, gaming, and various other industries that require reliable, real-world data inputs. Next one, Uniswap. It is a decentralized trading protocol that is, of course, going to be part of the DeFi lecture. The mission of it is to facilitate automatic and decentralized exchange of cryptocurrencies on the Ethereum blockchain. It's special for its use of liquidity pools rather than traditional order books, enabling efficient, trustless trading. The use cases include token swaps, liquidity provision, and yield farming. I know all of this sounds completely unfamiliar, but to get familiarity with these topics, I invite you to move on to the DeFi lecture. Meanwhile, number 16, wrapped Bitcoin. Wrapped Bitcoin is simply bringing Bitcoin liquidity to Ethereum, because Ethereum and Bitcoin do not naturally talk to each other. So, to bring Bitcoin to DeFi, the wrapped Bitcoin is used and created. And this special feature enables Bitcoin to be used for token trades, loans, and yield farming on Ethereum's DeFi platforms, enhancing interoperability between the two major cryptocurrencies. Another one is Litecoin, and this is designed to be a peer-to-peer cryptocurrency. It's designed to provide fast and low-cost payments by leveraging the unique properties of blockchain technology. It is special for its quicker transaction confirmation time and improved storage efficiency, in making it an effective medium of exchange for daily transactions and microtransactions. Cosmos or Atom. Another case for interoperability and scalability for blockchains. It aims to be the internet of blockchains. So, a network of blockchains that are able to communicate with each other in a decentralized manner. It's allowing for diverse blockchains to exchange data and tokens between each other. Then Terra Luna, a famous one, of course, not for the good news. It was a stable coin that actually ended up not being so stable. It was focusing, of course, on global payments, and that's how it reached its market cap and to be in top 20. It was also well integrated with DeFi applications and used for savings, lending, payments, and was there to simply provide the price stability. And the last one, number 20 out of 20, is Bitcoin Cash, which is a fork of Bitcoin. It is designed to be a peer-to-peer electronic cash, actually. It wants to be faster and more low cost for everyday use than the original Bitcoin. It's special for its larger block size, which allows more transactions to be processed quickly. And its focus is on retaining the original version of Bitcoin as a digital currency for everyday payments. That was the 20 top cryptos by market capitalization, but what about the blockchains that are the most utilized? Number one is Ethereum. It is very famous for its smart contract capabilities, hosting a vast ecosystem of DeFi applications, NFTs, and other dApps. Unfortunately, it's rather expensive. Second one is Binance Smart Chain. It is compatible with Ethereum's tool and dApps, but is offering lower transaction fees. It has attracted a significant number of users and developers, especially from the DeFi and NFT spaces. The transaction volume are almost rivaling Ethereum at times, especially during the DeFi activity period peaks. Number 3 is actually Solana. It is praised for its high throughput and low transaction costs. It has become a popular platform for a wide range of applications, including DeFi, NFTs, and decentralized exchanges. Why? Because the architecture of it allows it to process a large number of transactions, contributing to its high utilization. Another one that's also popular is Cardano, because it has a strong focus on research and security. It has gradually been building an ecosystem, also attracting projects in DeFi, NFT, and others. One of its upgrades introduced the smart contract functionality. That's why its utilization has been growing. And the last one, number 5, is Polygon. It is designed as a scalability solution for Ethereum and provides a side chain that supports a growing number of dApps and DeFi platforms, aiming to be faster and cheaper. It had a very large volume of transactions due to its role in easing Ethereum's congestion issues. It was especially popular during DeFi and NFT booms. With time, scalability solutions were becoming increasingly popular, and sidechain, like Polygon, is also a scalability solution. That's why it has increased utilization and helped alleviate the main congestion issues, and high fees. It also has a very large developer community and a still growing ecosystem of applications. I know that I said it is 5 most utilized blockchains, but there is a runner-up, Tron. Why? Because Tron is another significant blockchain for stablecoin transactions, particularly for Tether or USDT. Tron's version of USDT has seen substantial adoption due to its low transaction fees and fast processing times. This is something that makes it a preferred solution for the stablecoin operations. If you want to stay updated on the top news of crypto, I could recommend these 5 newsletters. Number 1, Bankless. It's a well-known crypto and blockchain media outlet that offers a daily newsletter of various content related to cryptocurrencies, DeFi, and blockchain space in general. It also talks about tactics, news, and narratives aimed at educating readers about the whole crypto industry. In addition to the newsletter, Bankless also hosts a podcast and a YouTube channel. They deliver fast-paced content to keep up with the rapidly evolving DeFi space. It is suitable for both crypto natives and beginners. The next one is Bloomberg Crypto. It's a part of the Bloomberg Media, a leading global multi-platform brand that offers news, analysis, and intelligence on various topics. So it includes business, finance, technology, climate change, politics, and so on. But of course, the focus on Bloomberg Crypto is on the crypto. It also provides news and analysis and intelligence, specifically about the blockchain space. If you read Bloomberg Crypto, you are also among investors, decision makers, politicians who are reading that as well. The third one is The Defiant. It's also a blockchain media outlet and it focuses on news and analysis, but it is also talking a bit more about the Web3 space. It offers a DeFi-focused daily newsletter and provides rather critical intelligence to investors and enthusiasts. They also cover very well Ethereum and Layer 2 scaling solutions. Another famous one is a Cointelegraph. It is a media outlet in the crypto and blockchain space that provides information about the cryptocurrency industry. They provide information also about the blockchain technology and mining and prices, but also about the utility of blockchain, which I like a lot. Moreover, they also talk about people in crypto. They were founded back in 2013, so Cointelegraph has a rather established position. The last one on the list is Decrypt Media. It is an outlet that is similarly talking about the blockchain technology and does it in a very interesting fashion. I actually would find that Decrypt Media is the one that has the most humor and jokes inside. It could be very useful for individuals that wants to see some insights into the crypto space. And it is operating somewhere on the intersection between emerging technology, alternative finance, and culture. They talk a lot about importance about Web3 and AI technology in its day-to-day operations.